least I never did it personally, because I was told though there's a function there. You can hypothetically put in the scores that you were going to be earning on the exam, on the homework, on the quizzes there, and we'll give you plus your current score, and we'll tell you what kind of grade you're going to end up with. So you can do that calculation on Canvas as well. But it's a simple math process there, and you just have to put all the points together and see whether or not it's still possible to get a grade that you want. And there will be no extra credit, and there will be no redo of the assignments there. So make sure you don't ask for those things. I won't be able to do it. And so whatever is out there, that's all the points that I have, and that's all the points that you need to earn. And if it's mathematically impossible for you to get a grade that you need, and then dropping maybe something to consider. Okay, so again, a pretty good result overall for the class there, and I am pleasantly surprised, or even I always feel happy teaching summer classes there, because honestly, I see people work hard and put in a lot of work and effort in this course there, and that makes teaching all enjoyable after all. So that's I don't have to deal with a lot of issues in the summer compared to my regular semester, fall and spring semester there, and so that's why I always I never hesitate to take over an assignment in summer. But this year though, this summer, it was a little bit different. We used to have 8 to 12:30 class, and then the afternoon class was 12 to 4:30. So this year, the division decided that we're going to do 8 to 12:30, 12:30 to 5. So this is the first year these two classes, back-to-back classes. There was an overlap before, but this year there was no overlap. And I thought about it a little bit, and I decided, no, I'll just give it a try. I'll do both classes there. It's a little bit tight in terms of time for me, but I think it's still a very enjoyable process so far. We got about 2 more weeks. Oh, well, actually 1.5 weeks to go. So Monday after next Monday, in 29th of June, that's the end. We'll have the final exam here. Okay, so we'll continue our discussion. If you have questions there, you will get your Scantron back either tomorrow or on Thursday. I'll bring in the folder, and you'll get your Scantron back. You'll get your next the quiz that you turned in yesterday, and you're gonna get the graded quiz back. So if you have questions, please talk to me as soon as possible. The third exam is coming up, and the originally scheduled date for the third exam is next Tuesday, and there is a possibility that I need to move that to the last day of lecture. That is the 25th. Well, 23rd and 25th. There's only 1 day difference there. But the third exam will cover chapter 6, 7, and 8. So that's what's going to be on the third exam there. So we need to finish chapter 8 before we talk about the third exam there, and then there's final exam. So there's really not a whole lot of time left for us. And in chapter 7 on Monday, I know that I probably overstretched a little bit, and I tried to dump all that quantum mechanics theory on top of you there. But that's a very complex theory. And I don't, as I said, and the scope of this course is not to get into the details about quantum theory. Rather, we're going to use, giving you the background of the quantum theory, the development of quantum theory there. How do we use that theory to make predictions about the electron distribution in atoms and in molecules? So the quantum theory is something that it's good for you to know, and if you want to get into the details later on when you take chemistry courses, and higher level chemistry courses there, you will get into quantum mechanics, and that's you do have that option there. But for the quantum theory that we introduced in this course, these are the 3 equations that I need you to memorize and be able to use these 3 equations to calculate frequency, wavelength, if one is given, C as a constant, so you don't have to memorize that constant, and then be able to determine the amount of energy associated with the radiation. If you know the frequency, if you know the or the wavelength there, using E equals to H times frequency, or Hc over the wavelength, and you should be able to calculate the energy. Now remember, that is the energy carried by one particular photon, and more than likely, when you have in radiation there, we're talking about billions of photons. So 1 mole of photon, 6.02 times 10 to the 23. That many number of photons, well, multiplied by the energy carried by each photon, and using this equation, you can determine, say, if you have 1 mole, 3 moles, 5 moles of photon with a particular wavelength or frequency there, using this equation, you can figure out how much energy is being carried by that radiation. Okay. And then, as we talked about the quantum theory there, one of the most important things in quantum theory is that now we understand electrons are being distributed in shells, meaning you have a ladder like a structure along. There are different steps there. The higher you go on the step, the more energy you have. So En represent the step. Okay. En, that's the energy for the electron on a particular energy level. En equals to negative RHC over n squared. N is the number of, well, it's the number of cell, or we call it quantum number, or principal quantum number. Okay. So these are the 3 equations that we need you to remember for the first learning objective. And then we're going to move on to the second learning objective. How do we use the what we have talked about to determine and to make predictions and to describe how the electrons are being distributed? So basically, we're trying to assign a particular location for electrons surrounding the atoms of different elements there. So in the learning these 2 learning objectives are pretty closely clustered together. So number 2, we want you to be able to explain the concept of orbitals and describe the basic shape of different types of orbitals. There we have what we call the s orbital, p orbital, d orbital, and f orbital, and so on and so forth. And then also we want you to be able to assign quantum numbers to the orbitals in a given main energy level. So if you have n equals to 1, well, there may be more than one sublevels in n equals to 1. Well, in n equals 1, there's only one sublevel. When you go to n equals to 2 or 3 or higher, there are more than one sublevels in there. So we need you to be able to assign quantum numbers to the electrons and in those different levels there, in those different orbitals there. So quantum number is our focus. We need you to understand how the electrons are being distributed. So how do we locate a particular electron? Well, I'll give you an analogy here, and if I need to locate you, if I need to send you $1 million check, well, school will send you $1 million check because you paid $500 for this course in the summer. So if the school is trying to mail you something through the post office, well, we have to know these things. The house number, which house you're looking at, the street name, zip code, city, and state. Okay, so these are the things that we use to locate a particular person by mail. And if you have all that information on the envelope, the post office hopefully will deliver. Okay, and the thing here is that if we try to locate an electron, same way, we have to know where the electron lives. Okay, so we need a set of 4 quantum numbers. Now here, the postal address, you have more than one. You can see postal address is more complicated than quantum number. More things in there, house number, street, and zip code, city.